Hello, this is the last set of notes for transformations. It is transformations of quadratic functions. So at first, let's review what a quadratic function is. Well, it must include an x squared, and these graphs form a parabola. So remember, that parabola is that U shape. Some examples of this are y is equal to x squared for an equation, or y is equal to x minus 3 squared plus 5. So this one on the bottom here, that's mainly what we're going to be working with. And if you remember, that is called the vertex form of a quadratic equation. So we're going to jump right into some examples. So we're going to graph it, tell the coordinates of the vertex and the axis of symmetry, and then explain the transformation. This is just like square root functions or absolute value functions. So we're going to look for moving it left or right, up or down, stretching it or shrinking it, and flipping it. So the first one, we have f of x equals x squared. Well, our vertex is at 0, 0. Because I haven't added or subtracted anything, my axis of symmetry is also at x is equal to 0. So if you really wanted to, you could sketch, we used to do this, sketch that axis of symmetry. And remember, that's where a parabola would reflect over that point, and I'm going to add my vertex in. So now, I'm going to pick some other x values to plot. I'm going to do x is equal to 1. 1 squared is 1, so that's going to go out 1, 1. If I plug 2 in, 2 squared gives me 4. And then I'm going to reflect that over, so I'm going to put a dot here. Oops, and I got to fix that one over here. That should be one more up because it should be 2, 4. And then also 1 here. And then remember, it makes that U shape. And our first graph is done. Now f of x equals x squared is our parent function. So we will be comparing everything to this. Our next one is g of x equals x squared minus 5. I don't have any parentheses where anything is added or subtracted from the x, so the x value of my vertex is still 0. The y is going to be negative 5 because it's shifted down 5. Axis of symmetry is still x equals 0. Now if I plug 0 in, I get 0 squared minus 5, which is negative 5. I'm going to plug 1 in next. 1 squared minus 5 is 1 minus 5, which is negative 4. If I plug 2 in, I get 2 squared minus 5, which is 4 minus 5, which is negative 1. So I'm going to start by plotting those, and then I'm going to reflect the other points over. So 0, negative 5, 1, negative 4, 2, negative 1. And then you could fill in the rest of your table. That's totally fine. But I'm just going to reflect it over instead. Save myself a little bit of time here. And then I have 5 points. And now I can see the transformation. That minus 5 in our equation shifts our graph down 5. So shifts down 5. Okay, let's look at 2 more examples. G of x equals x plus 2 squared. Well, in this case, that plus 2 is inside the parentheses. So that shifts our graph left or right. And remember, when it's in the parentheses or in the absolute value, it lies to you. So that means my vertex is now at negative 2. There's nothing added or subtracted outside here, so it's going to be 0 for the y. My axis of symmetry is x equals negative 2. So I'm going to start by plugging negative 2 in to my equation. When I plug that in, negative 2 plus 2 is 0. 0 squared is 0. So that's going to be my first point. And I already knew that because we have the vertex listed right here. So I'm going to pick some points to the right of that. So I'm going to plug negative 1 in. Well, negative 1 plus 2 is 1. 1 squared is 1. So negative 1, 1. If I plug 0 in, I get 0 plus 2 squared, which is 2 squared, which is 4. And now, if we remember before, I can reflect those points over my axis of symmetry. And then I can draw my graph right through. Okay, so transformation, in this case, I shifted, oops, let's fix that, but it's going to shift 2 to the left. And I can see that from my graph as well. All right, let's look at number 4. G of x equals negative 0.5 times x minus 1 squared plus 1. All right, this one's a little bit longer. Let's still start with our vertex. It's going to be at positive 1, because remember the parentheses lie, and then the y is also going to be positive 1. Axis symmetry is at x is equal to 1. So I'm going to plug in, I know I have the vertex at 1, 1. So let's draw that in. Now if I think about just what's given in my equation, well, this minus 1 shifts our graph right 1. This one shifts it up 1. And then we got to think about, what does this negative 0.5 do? Well, the negative will flip it. So I know that my graph's going to open down. The arrows are actually going to point down now. And the 0.5, remember when a is less than 1, is going to make it wider. So this kind of just helps me think about what my graph should look like. So now I'm going to pick a point to the right. So I'm going to plug in x is 2. Well, if I do that in parentheses, 2 minus 1 is 1. 1 squared is 1. 1 times negative 0.5 is negative 0.5. Plus 1 is a half. I'm going to keep going and try 3. 3 minus 1 is 2. 2 squared is 4. Negative half of 4 is negative 2. Plus 1 is negative 1. So I'm going to add those to my graph. And then I'm going to reflect it over. And then 5 points is enough to sketch the graph. So I'm going to go ahead and draw my graph. So I can see that my graph has in fact gotten wider and it opens down now. Alright, 2 more examples. So I have negative x squared plus 3. There's nothing in parentheses with my x, so this is going to stay 0. And this is going to become positive 3. My axis of symmetry is still at 0. Well, I know that negative sign in front of x squared flips it. So this is going to be flipped. And then that plus 3 shifts it up 3. And as for the transformation, maybe you have to graph it to help you see how it's transformed. Maybe you can tell from the equation. We want to be able to do both. So I know 1 point for sure, that's my vertex at 0, 3. Okay, so I'm going to plug in some other points. Let's do 1 and 2. Well, if I plug 1 in, I get 1 squared. After I square it, then I multiply by this negative 1 out front. So 1 times negative 1 is negative 1 plus 3 is 2. Plug in 2 next, do the squared first. So 2 squared is 4 times the negative 1 is negative 4 plus 3 is negative 1. So let's graph what we have now. So 1, 2, 2, negative 1. Reflect that over. And draw our graph. Okay. Let's look at our pink one. G of x equals 3 times x minus 6 squared minus 2. Well, that minus 6 in parentheses lies. So our vertex is going to be at positive 6 and then negative 2. Axis of symmetry is at x is equal to 6. So I know 1 point in my table, 6, negative 2. That's our vertex. I'll go ahead and plot that. Pick some other points close to that. I can see I'm going to go off the graph to the right. So in this case, I'm actually going to go back the other way and do 5 and 4. If I plug 5 in, I'm going to get 3 times 5 minus 6 squared minus 2. So I get 3 times negative 1 squared minus 2. 3 times negative 1 squared is 3 times 1, so I get 3 minus 2, which is 1. Now I can do the same thing with 4 here. Let's erase some of our work. So I'm going to plug 4 in for x. 4 minus 6 is negative 2. So it's going to be 3 times 4 minus 2, which is 12 minus 2, which is 10. Okay, so 5, 1. And actually, mine aren't going to really fit, so I'll reflect that one over. The other points are going to go off the graph, and that's okay. So as for my transformation, it shifted right 6 down 2, and it got narrower. And that's because of the 3 out front. Thanks for watching!